Welcome back everyone. In this video we're going to discuss triangles. Here we'll be discussing the Thales theorem. We will be also looking at some numericals. So without any further ado, let's get started. First of all, let us discuss what are similar triangles. Now similar triangles are basically two triangles if they satisfy one of these two properties. Okay, what are the properties? The first property is that all angles or all corresponding angles must be equal. That is, A equals D, B equals E, and C equals F. Then we can say that these two triangles are similar. Or if this property is satisfied, that is, ratio of the corresponding side, that is AB by DE, BC by EF, and AC by DF, if they are equal, then we can say that these two triangles are similar. Now similar doesn't mean equal. Let's say that these two triangles are similar. Okay, if one of the properties is satisfied, then we cannot say that this side is equal to this side. Okay, but their ratio is definitely same. Okay, let us now discuss the Thales theorem. Thales theorem, the statement is, if a line is drawn parallel to one side of a triangle, okay, let's say this is your triangle. So if a line is drawn parallel to one side of the triangle, intersecting the other two sides, that is intersecting the other two sides, then the other two sides are divided in the same ratio. Okay, that is, this two side is divided in the same ratio. Fine. So let's prove that. Given the triangle in which DE is parallel to BC, to prove that this upon this, that is this upon this, is equal to this upon this. Okay, the proof is very simple. We'll need to construct some lines. So what are the construction? Join BE and CD. So join BE and CD. Draw EP perpendicular to AP. So draw EP perpendicular to AB and DQ perpendicular to AC. Proof. Since EP is perpendicular to AB, this EP is perpendicular to this line, that is AB. Therefore, definitely EP is the height of this triangle, that is ADE. Also, it is the height of the triangle DBE. Okay. Thus, area of the triangle ADE, we know the formula is half into base into height. So half into base is AD. Okay, for this triangle, base is AD and height is EP. Also, area of triangle DBE is again half into base into height. So half into base is DB. This is the base for this triangle, and height is EP again. Okay, then therefore, if you divide this by this, area of ADE by DBE, then you get this. If you cancel, half and half will get cancelled, EP and EP will get cancelled, then you get AD by DB. Similarly, okay, area of the triangle ADE is half AE into DQ, since DQ is the height of the triangle ADE. Also, area of triangle DEC is half into EC into DQ. So this is your height, right? This is your base. This is your base EC. If you substitute, half and half will get cancelled, DQ and DQ will get cancelled, you get AE by EC. But triangle DBE and DEC are equal. So triangle DBE, this one, is equal to triangle DEC, that is this one. Why are they equal? Since they are on the same base DE. Okay, they are on the same base DE and between the same parallel line DE and BC. So this is one property. If you have two parallel lines, okay, and if you draw two triangles with the same base, let's say this is your base with the same base, then no matter where you draw the two triangles, okay, their area will always be same. Therefore, area of DBE is equal to area of DEC. If you take reciprocal, you get this, taking reciprocal. Then if you multiply by ADE both sides, you get this. Now ADE by DBE is nothing but this, and ADE by DEC is nothing but this. So if you substitute, you get this. So we get AD by DB, that is AD by DB is equal to AE by EC. As simple as that. How to remember this theorem? It's very easy. First of all, you'll have to remember the construction. The second thing you'll have to remember is you'll have to find the area of this triangle with this triangle, then again this triangle with this triangle, and you'll have to remember that these two triangles are equal. Then if you substitute, you'll basically prove this theorem. Let us now do some numericals based on Thales theorem. So the first question is shown on the screen. In triangle ABC, DE are the points on the same side AB and AC respectively, such that DE is parallel to BC. If AD is 2 cm, AB is 6 cm, AE is 3 cm, find AC. So given DE parallel to BC, then we know that by Thales theorem, this divided by this, or this divided by this whole thing, is equal to this divided by this. So given DE parallel to BC, we know that by Thales theorem, AD by AB, this by this, is equal to AE by AC. Then if you substitute, you get 2 by 6 is equal to 3 by AC. If you cross multiply, you get AC is equal to 9 cm. As easy as that. Let us do the sixth question shown. So here again, given DE parallel to BC, so we know that this is by Thales theorem. You'll have to mention by Thales theorem. This is there. So if you substitute, you get this. If you substitute A, you get this. If you cross multiply, you get EC is equal to this, which is nothing but 4.5 cm. Now you have to find AC. So AC is this, right? So AC is nothing but EC plus AE, which is equal to 4.5 plus 3.75, which is equal to 8.25 cm. If AD by BD is equal to 4 by 5 and AE is equal to 2 cm, find EC. Here we'll be using the same figure as was shown in the previous questions. So given that DE is parallel to BC, therefore by Thales theorem we have AD by BD is equal to AE by EC, right? By Thales theorem. So if you substitute, AD by BD is given to be 4 by 5, AE is nothing but 2, so EC. So if you cross multiply, you get EC is equal to 2.5 cm. Let us do one more question. It is given that AD is equal to 4x minus 3, AE is equal to 8x minus 7, BD is equal to 3x minus 1, and CE is equal to 5x minus 3. Find the value of x. So by Thales theorem, okay, we have this. So AD by BD, that is this by this, is equal to this by this. Now if you substitute all the values, you get this. You cross multiply, you get this. And if you solve here, okay, if you solve till here, you'll get this. Now here you middle term factorize, so you'll basically get this. Now we know that either this is 0 or this is 0. So x minus 1 is equal to 0, or 2x plus 1 is equal to 0. Then x is equal to 1, or x is equal to minus half. Since side cannot be negative, we have x is equal to simply 1 cm, right? Because this cannot be true. D and E are points on the side AB and AC respectively of a triangle ABC. Determine whether DE is parallel to BC or not in the first part. So given that AD is equal to 5.7, DB is equal to 9.5, AE is equal to 4.8, and EC is equal to 8 cm. So in order to do this question, we'll be using the reverse of Thales theorem. So Thales theorem says that if this is parallel to this, then we have AD by DB is equal to AE by EC. So reverse of Thales theorem will be, if you can prove this is equal, then basically they will definitely be parallel. So let's do that. These are the values that is given. From here, AD by DB is equal to 0.6 by substituting and solving. AE by EC is equal to 0.6 again by substituting and solving. So we see that 0.6 is 0.6. So clearly AD by DB is equal to AE by EC. Hence, definitely DE is parallel to BC by converse of Thales theorem. Let us do one more question. Similar. So it is given that AD is 7.2, AE is this, AB is this, AC is this. Again, we'll do the same thing. We'll find AD by AB and AE by AC. So if you substitute, this is what you get. So you get 0.6. If you substitute here, you'll get 0.64. So we see that these two are definitely not equal. So we can say that clearly this is not equal to this. So hence DE is not parallel to BC by converse of Thales theorem. As simple as that. This is one of the easiest exercise in this chapter. So kindly practice as many questions as you can, and if you have any queries, please drop it in the comment box. So thank you everyone for watching. I hope to see you in my next video. Take care everyone.